Okay, so you see that we come back to the steps again because we have completed the data processing part. Completed in the sense we have discussed few levels of data processing techniques. Okay, like missing value, the imputation on missing values, feature scaling, the categorical feature encoding, and maybe there are many more data processing techniques left for some advanced purpose. Anyway, so since we are just taking some very basic idea of doing creating a machine learning project, so we are right now we are bounded only those few data processing techniques only. Now what we can do, we can go further, and as you can see that in the next we have split data into train and test set. What is this? As I told you that we have a data set, right? You have a data set, and when you will get a data set, nobody will say you that this data is for training and that data is for testing. What basically in most of the cases we do, we divide the full data set after, obviously after we got a raw data set, we processed on the raw data in from various angle, and then the step that we have to do, we have to divide the data into two part. One part we will use for training the model as a known example, and another part we will use for testing or evaluating the performance of the model. Now, why you are dividing into two part? Why I cannot do the training on the all data set that we have received and also testing on the all data set we have received? It's something like you can imagine in this way, like when you study a particular chapter of some subject. Okay, um, it does not mean that the problems that you have basically solved to learn that particular subject, exactly the same problem come in exam. It does not happen, right? What happens? A similar type of exams come, similar type of questions come in exam, where the similarity in the sense maybe similarity with respect to the the technique to solve the problem, or the type of data that you have in the problem. In that sense, then it is similar, but exactly the problem that you are using to learn a particular subject, the same problem you use, same problem you basically solve during exam, it doesn't happen. A similar situation over here, like we are training the model with some set of data, and we will try to check how good the model has learned by some new data which is very close to the data by which we have taught the model, but not the exact the same data. Okay, then only you can at least ensure that okay, your model working good. Okay, so let's see what we have over here. So first thing is that we have to understand that what exactly the whole pipeline is. The pipeline in the sense that you have an entire data set and you want to divide, and finally you want to test. So what are the steps that basically we follow? So just assume that we have this entire data set. It's a raw data, or form a raw data, or maybe a processed data. Okay, so this is the entire data set. The first thing that we do is we divide the data in, you can say, vertical form. Vertical in the sense, in one side we have all the features, and in other side we have the output. So that I have represented x and y. So x means it's a, definitely you can easily understand that it's a data having only features, input features, which will be fed to the model, and the y represents only the output, only output vector. Okay, now what we do, we divide this thing into two parts that I just said, one for training and one for testing. How we are dividing? I'm coming later. Okay. So we are dividing into two parts. Then what we do? We do the training. We fed the training data to the model, and we are teaching the model with this data set. So the model training is happening with this set only. I mean, not only Y, just trying to understand, it's a, it's a combination of train X and Y. Okay. So after some iteration, definitely I can expect the model has learned. So now what we have to do? We have to basically test with the some data. Which data? The data that present here. So with this data, we can test the model. So if we feed the model, this particular test X, into the trained model, what we will get? We will get some result, right? And the result can be, say for example, Y dash. Now how basically we are evaluating that how good this model has been trained? Because I have fed this test X into the train model, and as a result I have got an output Y dash. Now according to my data set, this test X's corresponding Y already I have in my hand, and this Y dash that the model is predicting. So just by comparing these values present in Y and Y dash for different rows, you can easily check that how close the model is, right? Just by evaluating this Y and Y dash, because Y is the actual Y of this test X's, test data, and Y dash is the predicted Y by the model for this test data. So if the model is very good, if the model has been trained very good, so naturally this Y and Y dash will be very close to each other, right? And if it is very close to each other, then I can say based on some evaluation, obviously I must have some performance metrics. Performance metrics means some technique by which I can evaluate how close this Y and Y dash is, right? And based on those technique, we can claim that this model is very good. To some extent, sometimes we say that it's very good, it's giving 95% accurate result. What does it mean? It means for 95% cases, the model is predicting correctly. Something like this, in a very layman term, I'm saying. Okay. But what exactly it is, that we will go through with different performance metrics that we use for evaluating performance of any machine learning model. Okay. But before that, we have to understand how we are dividing this entire data into training and test set. Okay. So let's do one thing. So there are two different way actually by which you can do this. One we call repeatable train test split. What is this? Important consideration is that rows are assigned to a train and test set randomly. First thing is that when we are dividing, it's done randomly. But remember, these training points and the test points are basically representation of the actual problem. For example, I want to do some prediction of, say for example, I'm working in some finance company which basically uh, which basically give loan to different customers, okay, or maybe which gives credit card to different customers. So before a company decide that this particular customer is capable to take the credit card, the company must go through some set of verifications, right? So assume that I've designed a machine learning model which will take a lot of inputs about the customer. For example, the customer's bank accounts some specific information of bank accounts, some working history, the current salary, and many more. And according to by these inputs, the model can say that the person is eligible for getting the credit card or not eligible for getting the credit card. I mean, it's a classification problem, either eligible or not eligible, as simple as that. Okay. So, and the finance company suppose operates on the whole country. Okay. So, whole country is a very huge. Naturally, if I must have a very, and obviously it's a finance company, right? I must have a very robust model. Robust model in the sense, for there must not have a, anyhow mistake in the model. But you see, there are crores of people who can try to take credit card. But when, and those crores of people are from different region of the country, different regions, right? So when we will try to create the machine learning model, the data set that I will have, the data set of different persons, the person should not belong to a particular region of the country, right? Like eastern region or some south region. If you do that, then what will happen? The model will be trained based on a particular region of the country. But so it's not become a generalized one. Naturally, from all the, for all the other regions, if a new data come to check the eligibility, there will be a high chance that uh, the model will show some wrong result. So just assume we have a crores of data. You cannot train with crores of data, all the data. You can say, for example, list, I mean, picked up, say, lakhs of sample from crores of data. From lakhs of sample, that is the data you have. These lakhs of sample must represent the whole data set present in the represents the country, right? With respect to the language of statistics, this whole data set of all over the country we call population data, and the data that we are collecting, some particular percentage of data from the population we call sample. This sampling should be very good representation of the population. First point. If it is not a very good representation of the population, naturally the model will be biased. Biased with respect to some specific region, maybe, or maybe biased with respect to a specific age of people, or maybe biased with respect to specific salaried people, right? So there are a lot of different probabilities to get the biasness with respect to different cases. That should not be the situation. And not only this, but also when among this lakhs of data, when you are dividing the data set into train and test data, you must ensure that the distribution of the train data and test data remain almost same. What does it mean? Just for example, I am saying, suppose that you have divided up the full data set into train and test data, and you have train data set mostly from, say, south region. The salaried people from south region. Okay. And but in the test data set, most people are from north region. then what will happen? Naturally, the model will get trained by South Indian peoples, and you are asking the model for North Indian peoples. Is it possible to answer correctly for the model? No. The model should learn by both South and North regions. Then only the model can be generalized. And that is what actually is written on in this here. It is written, what is written? This is done to ensure that data sets are a representative sample of the original data set. Just what I said. Which in turn should be a representative sample of the observations from the problem domain. This problem domain based on the whole country. So just to explain this point, I shared this story. Anyway, always remember that when comparing these machine learning algorithms, it is desirable that they are fit and evaluated on the same subset of the dataset. That I said that you must not have like you trained with South Indian people and you are asking for North Indian or East Indian peoples. Not something like that. You must have a generalization of the full dataset. Now there is one more situation that there is some classification problems which does not have a balanced number of examples for each class level. For example, say a dataset of say healthcare data. So you have a data of patients. Okay, lot of patients, lot of different case histories, and some outcome as some having some particular disease or not. Say blood sugar or maybe say type 2 diabetes. So you have a database or data set of say hundreds of people. Naturally, there may be a situation that 90% of the people does not have diabetes. Only 10% of the people has diabetes in the dataset. So when you will divide the dataset into train and test part, you should ensure that the percentage of normal and diseased people in the train dataset should remain same as percentage of normal and diseased people in the test dataset also. If you don't maintain this, what will happen? Just assume a situation. You are dividing randomly into two parts, 90-10. By 90 data, you will be trained, and for 10 data, you will be tested. And suddenly, because of some error, the 90 data that you have chosen for training, all are normal people. And the 10 data that you have chosen, all are diseased people. Is it going to represent good? Is it possible to learn the model fairly by those 90 set of data? No, because in case of maybe the data is 90, but all the data are not diseased. There is no cases of diseased people the model has observed during learning. So naturally, the model will not be able to properly differentiate between a diseased and a normal person based on the features. That is why in those situations the stratified train test split is used. That's why it is written. It is desirable to split the data set into train and test set in a way that preserves the same proportions of examples in each class as observed in the original data set. Just what I have said. So how to do this? Just I'm showing you in a simple turn. Let's do one thing. Let's go back to the code and I'm showing you how to do this.